Hello, and today we're going to be going over USACO 2017 December contest bronze, and we're going over problem 3, which is milk measurement. So let's get started. So the farmer John purchases 3 cows, Bessie, Elsie, and Mildred, each of whom initially produces 7 gallons of milk per day. Since the milk output of a cow is known to potentially change over time, Farmer John takes periodic measurements over the next 100 days and scribbles them down in a logbook. Entries in his log look like this: 35 Bessie minus 2 and 14 Mildred plus 3. The first entry indicates that on day 35, Bessie's milk output was 2 gallons lower than it was when last measured. The next entry indicates that on day 14, Mildred's milk output increased by 3 gallons from when it was last measured. Farmer John has only enough time to make at most one measurement on any given day. Unfortunately, he is a bit disorganized and doesn't necessarily write down his measurements in chronological order. To keep his cows motivated, Farmer John proudly displays on the wall of his barn the picture of whichever cow currently has the highest milk output. If several cows tie for the highest milk output, he displays all their pictures. Please determine the number of days on which Farmer John would have needed to change this display. So basically, we can think of it as this way. So initially, all the cows produce 7 gallons of milk per day, and there are 3 different cows, right? And then the amount of milk that they produce can change over time. So Farmer John records the amount that it changes and which cow's output is changing and on what day. So this is the day, this is specifying the cow, and this is specifying the amount of how much it's changing by. So obviously, this just says that on day 35, Bessie's milk output is being reduced by 2. And suppose that the milk output is 7 all the way up to day 35. All this means is just that the milk output on day 35 will be 5 instead of 7. Here, on day 14, Mildred's milk output increases by 3. So assuming that the milk output was 7 gallons per day until day 13, on day 14, Mildred will produce 10 gallons of milk. Okay. So this paragraph is just explaining this, and this is saying is just that whichever cow has the highest milk output will be displayed on the barn wall, I guess. And all we're trying to do is just trying to find which cow has the highest milk output and how often that changes. So if we look at the input format, the first line of input contains n, which is the number of measurements Farmer John takes, and the next n lines contains one measurement in the format above, specifying a day, the name of cow, the change in the milk output, and each cow's milk output will always be in the range of 0 to 1,000. So it just gives us the input format and some constraints, and the output format is just please output the number of days in an integer in the range 0 to 100 on which Farmer John needs to adjust his motivational display. And as you can see here, we have a sample input, and this number n is just denoting how many measurements that Farmer John took. And then these are the measurements in the formula that I just explained above. And the sample input is just how many times the leaderboard of the milk changes, right? And so here is an explanation of the sample input and output. So initially, all cows have milk output 7, and on day 1, Bessie's milk output increases to 9. Remember that Farmer John doesn't take these measurements necessarily in a chronological order. So this is going to be day 1, right? And so on day 1, Bessie's milk output increases to 9. So everyone else is 7 and Bessie is 9. So she's in the lead right now. And so the picture on the barn wall will be Bessie. And then on day 4, Elsie's milk output decreases to 6. But this doesn't change the fact that Bessie is the sole cow in the lead, right? So on day 4, basically the milk output would be 6, 7, and 9, right? And because of this, I guess Bessie is still in the lead because Bessie is 9 right now. And then it would be Elsie is 6 and then Mildred is 7. So the lead doesn't really change on day 6. On day 4. So we're not going to change the display. And on day 7, Mildred jumps into the lead, changing the display, right? Because Mildred is going to be plus 3. And so she goes from 7 to 10. And so she beats Bessie by 1 because Bessie was just at 9. And then on day 9, Mildred drops in production to be tied with Bessie, again changing the display, right? So this might be a little confusing. So on day 9, right, remember how Bessie was 9 and Mildred was 10? Well, now Mildred is dropping back down to a 9. And so that's why the display is going to be changing. So let's actually visualize this, I guess, this on a kind of like a graph, I guess. So as you can see here, this is a visualization of how the milk changes. So we start off on day 0, where everyone has a milk production of 7, right? And then each letter is just the name of the cow. So this is Bessie, this is Mildred, this is Elsie. And so on day 0, sorry, we start off with 7 on everyone. And then on day 1, Bessie's milk production increases by 2. And then on day 4, the Elsie's milk production drops to 6. And then on day 7, Mildred's milk production increases by 3. And then on day 9, Mildred's milk production decreases by 1. So you can see that the milk production changes in 4 spots, right? And that's the red. So milk production changes here, 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 and here. But the display changes 3 times here, here, and here. All right, so the milk changes 4 times, but the display changes 3 times. Remember that we're looking for how often the display changes, right? And it changes here because the leader, right? It was all tied here, but there was a new leader, which is Bessie here, right? And then so Bessie is currently the leader all throughout here, and then the milk changes here, and so we check again, and it looks like Bessie is still the leader here, so there's no change, right? So that's why we don't have a C right here. And then Bessie is still the leader, and here we see that Mildred kind of overthrows Bessie, and Mildred is now the new leader. And then we keep going and we see that now Bessie and Mildred are tied. So now basically both Bessie and Mildred will be shown on the display. So the leaderboard, or I guess the winner, kind of changes again. And that's why we have a C here, because that display changes once again. So this is just how you can visualize the problem. Now let's move on to actually programming this problem. Okay, so now we're gonna start programming, and as you can see, I already have some code here. And so all this is this just the buffered reader and the print writer, so it's how I'm gonna do my file input and output. And I just have some code closing it, these two. And then I have 2 methods, right? This is my initialize method where I'm gonna make all my variables, and my solve method where I'm going to actually solve the problem. So first what we're gonna do is we're going to get some static variables, and these would just be the variables that we use throughout our program. And so you can feel free to pause the video and just look at which variables I'm using here. The names, obviously you can use your own names if you want, but this n here, right, this n is the first line of input, and all this is it's just the number of logs in Farmer John's notebook. B, E, and M are just the variables for the milk count of Bessie, Elsie, and Mildred. The output will be the number of times the display changes. The day array is just going to be, so when we get our input, we have lines that show the day that the milk was changed, the name of the cow whose milk was changed, and we have the amount that it was changed by. So the day array is just going to store the days on which Farmer John logged changes in milk. The adjust is going to basically record the amount adjusted, right, for each of these inputs. And you probably can tell by now, but the names is just going to record the names for each of the logs. And so these arrays will be side by side, and these arrays will basically just have the log, but in array form, right? And then we have 2 Boolean arrays, maxes and maxes1. And this is going to come into play a bit later, but all this is doing is it's just going to record the max at every time the milk changes, and then it's going to compare it to the previous version, which is going to be max1, and then we're just going to see if it has changed or not, and if it has changed, then we add 1 to the output, okay? So now we're going to go ahead and actually initialize these variables. So we're going to do that by having this code here. And so all this does is we have our variable n here, right, which has been initialized up here. And so we just read it in, and then B, E, and M are the milk count, and all of these are just going to be set to 7 because that's what it is at day 0. We have our max and max 1, right? This is just going to, we're going to use these a bit later, but it's just going to store which person has the max, or which cow has the max, and it's going to see if it changes each time the milk changes. And then we're just initializing these, right? And then it's pretty straightforward. And then what we do here is we actually take in the input, and then we, I guess, put it into the variable, if we put it simply. And so this is just putting in order of the input, right? The first thing that we're given is the day. The second thing that we're given is the names. The third thing that we're given is the adjust. I'm going to put the problem link in the bio, so feel free to just, switch back and forth with the program here and the problem page just to make sure that you understand what's going on. It's just that the input is given in this order, right? And then so we just need to add a quick exception here, right? And then that's all there is for the init, right? The initialized method is pretty straightforward. We're just taking in all our inputs. And then the solve method is kind of where it gets a little complex. So now that we have all of our, I guess, days, names, and adjustments in the arrays, what we're going to do is we're going to sort them in chronological order. Because as we know, it said in the problem that Farmer John does not necessarily have these measurements in a chronological order. So our first order of business is going to be making it into a chronological order, and we just do that by sorting the array. All this is doing is what it does is we go from 0 to n minus 1, and then we go from whatever I is, I plus 1, to less than n. And then all it's doing is it's just sorting it, right? So for example, let's say we have like one variable here, or one number here, and then another number way down the line. And if that number is, I guess, less than the number here, then we just swap the two. And when we do that, right, this is just a classic sorting algorithm. However, the reason why we don't use an arrays.sort or something like that is because we need to sort all three of them at the same time. So if we move, we're basically doing it by day. We're sorting it by day. The day has priority, right? But if we sort the day, then if we just do arrays.sort day, if we just sort them individually, obviously they won't have the same the order that we want. And so what we do is we manually sort it, and whenever we make a change, we make that exact same change for the other, I guess, the other arrays. And so, for example, if we have, I guess, if you look in the first line of sample input, we have Mildred 7 and plus 3, and then we have in the second line 4 Elsie minus 1. Now, if obviously we want 4 to come before 7, right? So when we switch them, all we're doing is we're just swapping everything, all three arrays, right? That's what this method is doing. And it's actually pretty straightforward when you look at it. It's doing the same thing for each array, right? I split it up into 3 parts to simplify it much further. And then we're going to move on to the next part of our solve method. And so what we're going to do is we're going to open up a for loop, and we are going to, so what we're going to do here is we're going to compare with the names of, I know this is incomplete, but just bear with me. So we opened up a for loop from 0 to n, and if names.I is equal to Bessie, then all we're doing is we're just adding the adjustment amount of the milk to B, right? So all this is doing is it's just changing the B, E, and M variables, right, which hold the milk production, right? We're just changing it to the adjustment amount, right? So it's not, if you refer back to the timeline, I guess I made in the video, I have like 0 through 9, all the numbers. But right now, all this is doing is it's just going through the specific days when the milk changes, right? Because in the, I guess the timeline, I put all the dates just so that you can think of it from a human perspective where we go through every single day. But I guess here it's more like we really, those are kind of obsolete, and we just really need to see the days that it changes. And so moving on, we have an integer here called max, and it's just taking the max of b, e, and m. So we take the max of b and e first, and then we compare that to m, so we get the max of 3. That's how you find the maximum of 3 integers. And now what we're gonna do is we're going to compare the maxes and see, right? So if Bessie is currently the max, then what we're gonna do is remember that the maxes array are just booleans. So it's all it is it's just saying we have like Bessie, Ellie, and Mildred, and Bessie, Elsie, and Mildred. And if Bessie is the max, then it's set to true. And if Elsie is the max, that's set to true. And you guys get the idea. And the rest of them are just gonna be set to false. Okay. And so that's just doing it for every single cal, right? So if b is equal to max, then max is 0 equals true, else max is 0 equals false, right? And we do this for every single letter, right? Every single cal, pretty straightforward, right? And so once we have made our maxes array, here's when we compare it to the previous, the previous maxes array. And so if arrays dot equals maxes 1 and maxes, right? So it's basically what this is saying is if the maxes 1 and maxes array are not equal to each other, right? Then all it's going to do is it's going to increase the output, which basically all this means is that, hey, if the max cow, right? So if the current winner with the most milk production has changed, then we're just going to mark that as a change and we're going to increase the output because our output is literally just recording how many changes there have been, right? And so that's all that this line is really doing. And we're almost done with our code. All we have to do now is just, move the new maxes to the old maxes. Now, the reason why we do this is a little bit above our code, right? We can see that you have to compare the old max and the new max. And so in order to do this, right, we first obviously have to make the old max. And so we just do this by putting the new max into the old max and doing that for every iteration. And then all we do is we close our for loop that has been giving us, white, and we want the color. And then we're just gonna do out.println, and then we just print out our output. And this is our completed code. And we can submit our completed code here, right, by selecting Java and then finding the file, submitting it, and we can see that our code is passing the test cases so far, and it passed. And so that is milk measurement. I hope you guys found that helpful. If you have any questions, please feel free to leave them in the comments and I'll try to answer them to the best of my ability. And thank you for watching.